Okay, we're just going to go over a quick detail from the last video I posted. It's not something you need to worry about at A-level. It's just if you're interested. And it's a detail of what happens to the absolute value when you integrate here. Because in the question, and I'll put a card on screen so you can go back and watch if you want to. You don't need to go back. But yeah, what happened in the question was we just ignored the absolute value. I just said you can just treat it as a normal bracket and that's fine. So what happens if you don't? Well, we have to start by talking about the integral of 1 over x dx. And because you've all been told this will be natural log absolute value x plus c. And it's not strictly true, okay? It can be slightly more complicated than this. So this function here, what we have, this would be, well, ln of absolute value. We know the absolute value doesn't change x if x is positive. But if x is negative, the absolute value becomes negative x. Okay. And in reality, the integral can have different constants in each different section. So it can actually be ln x plus c1 if x is a positive number, and ln x plus a different constant, ln negative x plus a different constant if x is negative. Okay, because this function here, it still differentiates to 1 over x. Okay, so we know that the usual thing that differentiates to 1 over x is natural log, which is this. Okay. And then we might have the other branch. So this is kind of our first function here. But the point is you could shift one of these branches up a bit and shift the other one by a different amount. And you can change them separately of each other because there's this discontinuity here, x equals 0, right? 1 over x also discontinuous at 0. So when you add c, you can add a different c for each separate section. Okay. Let's see how that actually plays out. So we can just very quickly recap what we did. We put all the h's onto one side and integrated, and the same with the t's. And I said, okay, this was negative 240 natural log absolute value 24 minus 5h equals t plus c. And now we have to go into different cases, right? If 24 minus 5h is a positive number, then this just reads as a normal bracket. That's just like so. I'll call that C1. And then I'll have a C2 in the other case. Let's just work this one through. So this is what we did in the question. So I think we divide by 240 and then exponentiate it. So like this. And then we said, I think that what we got told was that when t is 0, h is 2. And this is actually why this is the correct branch to go for, because h being 2 does satisfy this inequality. You can work out this inequality is true exactly when h is less than 4.8. So for any sort of starting height less than 4.8 meters, this is the correct equation. And you work it all through. So when h is 2, this becomes 14. And then, well, when t is 0, this just becomes e to the negative c1 over 240. Yes, oh, what we did actually, sorry, we just got rid of that. If you go back and watch the video, when I divided by the 240, I'll call it d1, we said that c1 over, we said c1 over 240 could just be written as d1, or I guess negative c1. So you can just sort of put the constant here. It's a bit easier. So this just gave us e to the d1. So d1 is natural log of 14. Yes. So 24 minus 5h is e to the minus. So it'd be e to the minus t over 240 times e to the d1, and e to the d1 is just going to be 14. So this will be 14 e to the minus t over 240. And if you put in, and we did all this last time, if you put in t equals 0, this does work. And then you rearrange, you get h equals, let's see, 24 over 5 minus 14 over 5 e to the minus t over 240. And on the graph, it looked like this with a horizontal asymptote at 24 over 5, which is 4.8. And it started off at 2 and went up. So what happens now is the interesting part, right? If 24 minus 5h was less than 0, I would take the opposite part of the solution. So I wouldn't do the log of x, I would do the log of negative x, right? You can't take the logarithm of anything negative. So I do ln of not 24 minus 5h, but 5h minus 24. And it's be a different constant, b2. Again, dividing, so I show that step again, where I divide the t by 240, but I'll just call this d2, just to rename a constant. And what do we get? We get e to the d2, which is like our constant, times e to the minus 2 over 240. And I mean, if you put the initial starting condition of t equals 2, well, that wouldn't make sense because we're saying we're in the case where h is greater than 4.8. So let's say instead of the tank starting at a height of 2, let's say if this wasn't our initial condition, I'll put it at like 5, right? I mean, I'll put it at 10, anything. Right? The tank can be taller than 5 meters, so it doesn't matter. So let's say here, when t was 0, h is 10, make it up. In this case, that becomes 50 minus 24 equals e to the d2 times by 1. So e to the d2 is 26, and the final equation is 5h minus 24 equals 26 e to the minus t over 240. So h is actually going to be 26 over 5. No, 24 over 5. Got that wrong. 24 over 5 plus 26 over 5. This is our solution here. And this is a very different structure to our other solution. Okay, if I zoom out, our other solution, we were taking away the exponential. Here we're adding on the exponential. And if you graph it out, it's going to have the same asymptote because as t goes to infinity, it's still just going to be 24 over 5. It's still 24 over 5. But now it starts up at 10 and comes down. Right, so the final solution, if your starting point is beneath this 4.8 asymptote, like it was in the question, the water would slowly rise and then just sort of tail off like that. But if you started off, make it a bit bigger, if you started off, there we go, h, if you started off higher, you started off at 2, you started off at something like 10, the water level would actually decrease and then sort of taper off again like this. Okay. Yeah, this is the extra solution you get if you consider both possibilities of this integration. Again, do not need to worry about this. This is just for your own interest. But I hope that kind of shows what I was talking about. You can always do this when you integrate with log. There's always going to be two possibilities depending on the sign of what's inside that logarithm. So, yeah, that should clear it up. Let me know if not. And I'll see you next time.